Hello viewers, welcome back to my technology channel on YouTube GTech. Believe me, this is an exciting video that I am bringing in today. As the title suggests, it's a power bank, but it's not the regular power bank that you find in the market. It's a unique power bank which can give you any custom voltage that you require. For example, in my case, I required say 12 volts, and I have built this unit accordingly. I also have some modules which can further step it down to some required custom voltages, which I have done it for myself. In fact, it can also be set inside itself for required custom voltage. So one other beauty of this product is it can deliver reasonably higher amounts of current compared to your regular power banks. For example, my gadget that I have built here can deliver up to 6 amperes. It can be set to deliver 9 amperes, but I have set it to deliver 6 amperes. Of course, this prototype can be further improvised or modified to whatever higher voltage that you would require for your custom requirement. It could be even 48 volts or 60 volts, even currents. Probably you can build it to deliver 20 amps or 25 amperes of current. So it's your improvisation. So I built it around 6 months back, and first of all I tested it using a custom test bench that I developed myself, and subsequently I tested it in the market. In the sense, like, I tested it in my domestic requirements as well as my professional requirements. For example, I tested it in charging my cell phones. I tested it for my router switches. So I tested it on my professional video cameras. I tested it on my live webcasting equipment. And I also tested it on some critical medical equipments like BiPAP machines, say nebulizers, digital BP monitors, etc. So I may have tested it for about 50-60 cycles now, and each time I may have tested it right from say an hour to say 3 or 4 hours also. So it has performed flawlessly. This particular combination of a circuit, whatever I have developed, has worked flawlessly, and I think it can even be manufactured in mass. So further in this video, I am going to discuss more about the technical aspects of this product. So I'm going to share several details so that anyone watching this video can try it out, try to build one themselves. Further, if someone needs more help, they can contact me. I can even help those people who want to manufacture such a product. I can give them the required know-how and help. So let's continue. So I started with the first prototype with this unit at the center that I have here. So this was the initial prototype, and subsequently I made 2 more prototypes, improvising with respect to circuit as well as form factor. So let's take the latest version, and I will explain about the features that we have here. So basically it has 2 outputs, and each output gives about 12 volts and 3 amperes of current. I have restricted the current to 3 amperes. I could have set it to say 6 amperes or even 8 amperes, but for my requirement it was 3 amperes, so I have restricted it to 3 amperes. So each output is controlled by a switch here. So there are 2 switches controlling 2 outputs. So then when I switch on this, when I connect an when I connect it to some gadget and switch it on, so there is an indicator here. So white LED indicator indicates that everything is normal and it's working fine. So in case the battery is discharged beyond a certain voltage, certain minimum voltage, so it automatically cuts off and the red indicator comes on. So other than that, so I have a battery level indicator here. So if you check, if I click on this, it will show the battery level. So currently it is showing 100%. So it is fully charged. So on this side I have two more sockets. So one is for charging. So for this I was able to procure a charger ready-made online. So a 16.8 volts lithium-ion charger which can give about 3 amperes, which was enough for my charging requirements. So I just modified the sockets or whatever you call this. So as per my this thing. So the next thing is I have one more socket here which is also very important. So it's called as battery health monitor. So I have a battery bank inside. So on regular basis one needs to monitor whether all the cells are working properly, all the cell voltages are proper. So for this I have a small external unit such as this. Say for example if I connect this here, so here, so I get the indicators of all the individual cell voltages. So in this way I can continuously monitor the health of this battery bank. Continuously in the sense I need not connect it continuously. So whenever, probably once in a week or once in 10 days, I can just connect this and check whether the battery bank is working properly. So this is for safety and also to see that this works flawlessly. So this is about the features. So of course there are a lot of technical features inside of this gadget. So externally I made it as simple as possible, so anybody can just plug in something and use it. So one other very important thing is I have used some specific connectors. So these are not regular connectors that you see in say regular DC jacks that you see in most of the gadgets. So I made these because by mistake someone should not plug in something here and which probably would harm the gadget as well as this battery bank itself. So the other thing is, so each one of these sockets are different. So one is 5 pin, one is 6 pin, one is 4 pin, like that. So that you can't interchange, and even by mistake you will not put something into something and burn it. So accordingly I have devised it. So now in the next step let us see general circuitry block diagram of this, and also we will look into the inside of this. So let's take a look at this block diagram. So it's the block diagram of the circuit that I have used inside the battery bank. So let me clarify this. So I have not developed this from chip level or say component level. I purchased various ready modules that were available in the market, which have already been tested and working at places. Then I put together those components and made this prototype. That is first thing. Secondly, it is not as simple as that, because to arrive at such a working configurations, I've done a lot of research and development, probably spent a lot of money on this. So to explain this block diagram, say it starts with a lithium-ion battery bank. So this battery bank was constructed by me using individual cells. So here in this case I used a 4x4 matrix sort of a design. So it is a 4S design, so which means I get a maximum voltage of 16.8 volts. So then this is connected to a circuit called as battery BMS, or say battery management system, plus a battery protector, so which protects it from say short circuit or say under voltage, etc. So then this also facilitates for battery health monitoring. So once again, that's a different circuit. Then we can also connect it to battery level check. So the output of the battery BMS, so it goes to DC to DC converter. So in my case, I have used a buck boost DC to DC converter, which means it can either step up or step down voltages. So I will specifically tell you what were these modules, but to start with, in this block diagram, I'm just giving you a general idea. So then the output of the buck boost is something which you connect to your gadget. And at every level, as you can see, I have protection, that is I have fuses in place, or you can also add any other say protection circuit. So then from the battery BMS itself, like you also connect it to a charger. So I showed you the charger, so that goes to the AC outlet, so you can connect it to AC outlet and charge it. And my charger gives around 3 amperes of current, and with 3 amperes I'm still able to charge it from 0 to say the 16.8 volts actually is the maximum voltage. So so it charges in about 5 to 6 hours, or say less than that, because usually you don't drain it fully. If it is drained fully, it might take about 5 to 6 hours. Actually, the battery specification of whatever batteries that I have used, it says that I can charge each cell at around 1.6 volts. So which means probably if you beef up your charger, it can charge in about 2 hours or 2.5 hours time maximum. So but to be safe, actually I'm using a lower current charger, and it is still charging very well, and it is serving my this thing, and probably I've used it for about 50, 60 or 70 cycles now, and even the charger that I'm using is working flawlessly. So now let us look into the inside of the build that I have here and see like how it looks. So here is the inside of the battery bank that we have prototyped. So as I explained in the block diagram, so here is the battery bank part. So it has been constructed using individual lithium-ion cells such as these. So these have been put together, series and parallel, and I have obtained a 4S battery bank out of it here. So that is the first part. So the next part is, so on this itself I have a circuitry here, and this is the battery BMS, and it also includes a battery protection circuit. So this is that module. So then you can see this blue circuitry here. So that is the buck boost converter. So it's a DC to DC converter, and the design claims that it's about 98% efficient or something like that. But I don't know, like when I practically tested it, so it's around 88%, it showed some 88% efficiency. in my calculations. So in this case, in this particular model or prototype, so I have two of these circuitries, so which I have wired individually. So the two outputs that you are getting here comes from individual buck-to-buck converters. So if there is a failure in one of the circuit, in emergency cases I can use the other circuit. So that is one reason. Second reason is, so when I have two circuits here, so it's possible that in each of these circuits I can probably obtain the higher amount of current. For example, 8 amperes here in one circuit and 8 amperes in another circuit, provided the battery bank is able to give that much amount of current. So in my case, in my case here, in the battery bank case that I have done here, so according to the manufacturer's specification, so it can deliver up to 3 amperes of current. So and when I have 3 of them in parallel, so it can deliver up to 9 amperes. So so that's about this, and obviously like have all these sockets and switches, connected LEDs, etc. So that's the inside of this. So if I get enough viewership, I will probably make a video wherein I will show you step-by-step construction of the whole product. So finally, I will tell you about the individual circuits that I have used. So I forgot to explain a couple of other modules that I have and that I use with this circuit. So as I told you, so I have set the voltages to 12 volts here. So let us say I have some gadget, for example I have a video camera, so that requires about 8.4 volts. So for that what I have done is, I have done some external modules such as this. Once again, these are made with the help of buck converters, so DC to DC converters. So what I do is, I connect these two, for example, let's say I will just connect and show. So I connected it to one of the sockets, so which was delivering 12 volts. And if you check here, so the output of this module, for example, so it's around 8.42 volts now. So so when I connect the load, it becomes 8.4 or say one a little bit lesser. So this can power gadgets which require 8.4 volts. For example, I use it to power my video camera. So similarly, I have one more module here. So this actually, steps down the voltage to 5 volts. So I use this to charge my cell phone sometimes. I use it to power my, small routers, etc. So I will show you, for example, I don't have an indicator here, but it works. So this specifically I have put an indicator. So this was an initial version, so this is the latest version. So when I made the latest version, I thought like putting an indicator is very important, so I put the voltage indicator. So like this, we can develop modules. So with any custom requirement, so even the current can be limited to the requirement that we have. So this is about the modules that I can actually connect to this unit and use it for other gadgets. To arrive at this product, so don't think that it was an easy ride for me. In fact, I invested a lot of money, I invested a lot of time in order to figure out what is the best combination of modules, those available in the market, that I can put together in order to create a successful prototype or say a working model that can be individually constructed or say even manufactured. And also many times procurement itself is very difficult, because sometimes these were available, sometimes these were not available. Certain things which I procure, sometimes it worked, sometimes it not worked. So finally arriving at a proper combination. So it took quite an effort. So if you can see this box, everything in this box actually was purchased in order to test out different combination, test out different things for developing this module. And also, like, I created my own test bench, in fact in couple of ways, in order to test it in harsh environments. It's a little bit funny, but I developed a test bench using brushless motors, those used in RC applications, and then used a electronic speed controller, and connected I connected a signal generator, and I connected ammeter, voltmeters, and then tested it using different loads. So in this way I was able to test it harshly. I was able to test it for a longer duration of time. I was able to test it in every way, and I was also possible to estimate the efficiency of this whole system. So this particular combination of circuitry, whatever I have used, did pass all the tests that I conducted. And finally, of course, whatever you might test it in lab, it has to really work in practice. So it worked fantastic when I took it outside and made it work in real time. So I used it fairly regularly with my live webcasting equipment and media cameras. So I used it with lighting system, LED lighting system. For example, even in this video, this particular box that I have is powering my LED lighting system. So this is the effort that I have put. So lastly, I will just explain the key components, the key components that I've used here. I will just show you the samples. So with this, I think you can start constructing one yourself. So finally, let me explain about the key components, those used in this project. So to start with, I constructed the battery bank using these individual cells. So I put together these individual cells. So I used a nickel strip to solder the series and parallels. So sorry, I've soldered it. Actually, I should have welded it using spot welder, but since spot welder was not available, I took the risk and I soldered it. So these individual cells come in 3.7 volts, which can be charged to 4.2 volts maximum, and their rating is around 3300 milliampere hour. So I've used 3 of them in parallel and 4 of them in series. So it's a 4S battery bank. Okay. So Panasonic batteries, remember. There are other company batteries that depending on your requirement you can use them. So the second one is I don't have a proper sample here. So usually a BMS circuit looks like this. You can see here, I think this is a 3S. A 4S will be a little bit bigger. I don't have a sample here because I've used all of them. So if you want to purchase this, go to Amazon or so go to internet and you can search for it and purchase it. So the other key component is this one. So this is the buck boost converter I have used. So this is a fantastic circuitry. So it has many features in it, including auto cutoff, everything. So low voltage cutoff. You can limit the current. You can set the voltage to your required output. So it's a buck boost. Even if the voltage goes below the output voltage, so still below the input voltage, still it can give the output at the same exact set voltage. So a beautiful piece of circuitry. It also has short circuit protection and everything. So then I'll tell you the model number. It is LTC3780. LTC3780 is the model number. It's available online. So I think it's available across the globe. Wherever you want to, you can purchase it. So the individual Panasonic cells, actually I purchased it in the local market. And the box for this, I actually purchased it in the local market. So I have made a separate video for this on where to purchase cases for robotics projects. So this is pretty much it. So for all those people who at many times require battery backup at critical junctures, especially media people and especially some medical practitioners, say, when they work at remote places, when they don't have proper setup. So this is a boon for them. So anybody who requires, say, mass manufacturing, who feels that they want to mass manufacture this, so I have done a lot of research on this, so they can contact me. Further, the same can be improvised to develop any battery bank that is required for e-bikes, so bigger ones. So the same process, it's the same concept, but just further improvisation. So I hope you like this video. Thank you. Good luck.